Now current shunt feedback. So output side, you will see the term current, so current source. Okay. Input side, you see the term shunt. Input side, you see the term shunt. So definitely you will be having current source at the input side also. Okay, the input side is also going to have the current source. It's clear from the name current shunt output input. Input is shunt. So whenever you have the term shunt, you will be having when you will have a shunt resistor only when you have a current source. So you will be having current source parallel with the resistance in current shunt feedback, and the output side is current, so you will be having a current source. And this current shunt feedback amplifier is going to be a current amplifier. Okay, so this will be the common ground, and you see here output side is very simple. AI into II, current source parallel to R0, parallel to RL. Simple. And across RL, you measure V0. Always current coming out of amplifier is I0, and this I is drawn to indicate when we are finding the output impedance. And excluding RL, you find R0F. Including RL, you find R0F dash. Input side, you see current source parallel to resistor. But for current shunt feedback, the beta value is IF by I0, or IF is equal to beta into I0. Since you have IF, it is going to be current source. And this will come in parallel with your source. So IF is equal to beta into I0. Okay, and direction is opposite because we are dealing with negative feedback. In negative feedback, the signal is subtracted. So the sign will be naturally opposite. When you have voltage source also, we had minus plus like this. It is opposite because it is negative feedback. Since same way current source also, normal means you will be drawing it like this. But since the signals are subtracted, so you will be drawing with the reverse direction. So IF will be flowing downwards. Whatever current going into your amplifier is II. The voltage across the amplifier is VI. So this is going to be the circuit diagram for current shunt feedback. Both the place you have shunt. So
சார்
definitely, yes.
சார் அந்த ஷண்ட்டு மட்டும் கொஞ்சம் எக்ஸ்பிளைன் பண்ண முடியுமா சார்? ஷண்ட்னா என்னன்ட்டு தெரியல.
Shunt na, it is called as parallel.
ஓ
Another term
ஓகே
for
சார்.
parallel is shunt. So shunt na, you will be having mostly, see, in the current shunt feedback now, first current indicates the output side, shunt indicates the input side. So input
ஓ
side shunt means some resistance is coming in shunt parallel. So when will resistance come in shunt? Only when you have a current source. So input side you have current source parallel to a resistance. This resistance is going to be RS.
ஓகே
And output side current varadnala, you will be having one more current source parallel to R0. See, series and cascade or a meaning da. So sometimes we use series, sometimes we use cascade. So which means that the components are connected like this. So two components connected back to back is series. Parallel means it is also called as shunt. So you have one component in parallel, you will be having one more component like this in shunt. So ஷண்ட்டில் வந்து
ஓகே
கரண்ட் டிவைட் ஆகும், சீரீஸில் வோல்டேஜ் டிவைட் ஆகும். Okay,
ஓகே சார்.
so remember
ஓகே
another name for parallel is shunt. So just notation kaha they are giving this shunt, otherwise shunt and parallel have the same meaning. Okay,
ஓகே சார். தேங்க்யூ சார்.
yeah. So see here in input side also you have current source, output side also you have current source. So this is we will first identify what is the current